Hello everybody, getting ready to do Algebra 1 Math 1.8 Part 2 today, classwork. And on 1.8 Part 2, you got 22 points to go on your classwork sheet. Have that out in front of you now, students. Put your name, date, period here on your phone, your tablet, your Droid, your iPad, your iPhone, your Chromebook. Let's go. And page 1 of Part 2, we're going to go right into an example. Example 3, write a function rule for a graph. So here's our graph. Write a rule for the function represented by this graph here. So step 1, make a table for the graph. So we need to make a table when x equals 1, y equals 2. When x equals 2, y equals 3. When x equals 3, y equals 4. When x equals 4, y equals 5. When x equals 5, y equals 6. So there is our table. There's our graph. Now what do? Identify the domain and range of the graph. Here is our domain. Here is our range. So we have our inputs, our outputs. All done. So now what do? To write a rule for that graph? What do? So find a relationship between the inputs and outputs. Notice from the table that each output value is one more than the corresponding input value. So yeah, it seems like 3 and 4, 4 and 5, 5 and 6. Yeah, that looks right. So write a function rule that describes the relationship y equals x plus 1. So that was the function for that table. A rule for the function is y equals x plus 1. The domain of the function is 1, 2, 3, and 4. Here's your domain, and 5 actually. And then the outputs are 2, 3, 4, 5, and 6. So there it is. Let's go up here to our guided. Write a rule for the function represented by the graph. Identify the domain and range of the function. Here's our graph. You got the same thing down here, students, and you're independent. So we're going to go do our guided right now from this here. We're going to write a rule. So write a rule for this function when x equals 0, y equals 5, and it goes that. So we have a negative slope. Make a table for the graph. Here it is. 0, 5, 1, 4, 2, 3, 3, 2, and 4, 1. Those are our ordered pairs. So the relationship between the inputs and the outputs are from the table that each output value is 5 more than negative 1 times the corresponding input. So that's kind of cool. It's is 5 more than the negative 1 times the input. So there is your relation. There it is there. There's your inputs. There's your. So knowing that fact, what do? Notice from that is 5 more than negative 1 times the corresponding input. Therefore, it's negative 1 times the corresponding input. So negative x plus 5. Boom. There it is right there. There's your rule for that graph. So y equals negative x plus 5. We noticed that there is a negative slope on that graph, so we knew x would have to be negative for sure. And so a rule for the function is y equals negative x plus 5. The domain of the function is 0, 1, 2, 3, and 4. The range of the function is 5, 4, 3, 2, and 1. There is your range. Let's go into another example here. Example 4, this is on your class worksheet, students. Analyze a graph. So guitar sales. The graph shows guitar sales in millions of dollars for a chain of music stores for the period 1999-2005. So here it is, years since, and then your outputs, your dollars. Identify the independent variable and the dependent variable. Describe how sales changed over the period and how you would expect sales in 2006 to compare sales in 2005. So the relationship does seem linear, which is odd. The independent variable is the number of years since 1999. Here's your independent variable down here, which is x. The dependent variable is the sales in millions of dollars. Here's your dependent variable here. The graph shows that sales were increasing if the trend continues, sales would be greater in 2006, which would be here, about here, than in 2005. So that would be the way to look at it. Let's do our guided now. Field biologists collected and measured alligator snapping turtle eggs. The graph shows the mass M in grams. So here we are here. Mass is your output, length is your input of an egg as a function of its length L in millimeters. Here's your length here of the eggs. As the lengths of the eggs increase, what happens to the masses of the eggs? So that should be fairly obvious. This is your independent down here, students. We're going to respond to our guided up here. So as the lengths of the eggs increases, here's your lengths down here. It seems like there's a general trend here that the mass increases as well. As the lengths of eggs increase, the masses of the eggs also increase, so that seems pretty obvious. And, well, let's sum it up here. Let's come up. What have we been talking about here for the last couple lessons? Ways to represent a function. You can use a verbal rule, an equation, a table, or a graph to represent a function. So we have verbal rules, equations, and tables. So the output is 1 less than twice the input. This would be the equation from this verbal model to the algebraic model to now the table model. And then we can finally graph the thing as well. Here will be the graph of that as well. So we've been covering verbal rules, equations, tables, and then the graph. And that's your lesson for today. Animated PowerPoint math video at AOL.com for questions or course materials. Thank you very much.